Let's take a look at an SAT math question that shows the importance of understanding special triangles. So the question we're going to look at comes from the October 2017 exam. If you're familiar with Khan Academy, you can find a copy of this test. They call it practice test number 9. So if you can find that, you can look at section 4, which is the calculator math section, and this is question number 31. So here's what the question looks like. It says, in the xy plane above, the circle has center hk and radius 10. What is the value of k? So before we talk about it, take a moment right now, pause the video if you want to, and see if you can figure it out. Okay, so now you've had a chance to look at it. Maybe you've got an answer, maybe you're stumped. So let's talk about how this question works and why this question is actually very illustrative of the importance of special triangles. Okay, so look at what we know. We have a circle here. We've got 2 points. We've got the center hk in the xy coordinate plane. And we can start with the information that we know, right? So the question gives us that this has a radius of 10. So it's always helpful to draw on our papers here, right? The SAT gives us a copy of the test. So let's go ahead and draw in 2 radii of this circle. So we'll just make some lines from the center hk to those 2 points 4, 0, and 20, 0. Right, now we know that those 2 lines must both be 10 because they're both radii of the circle, and the question tells us that they measure 10. So we can safely draw those in there. All right, so ultimately we need to figure out the value of k. So to get there from here, what can we do? Well, let's draw another line that goes from the center of the circle down to the x-axis. So let's just drop a vertical line there, make a little right triangle here. All right, so now from here, we can figure out the length of the chord between the 2 points, right? So if one of them is 4, 0, the other is 20, 0, then the distance between them must be 20 minus 4, which is 16. Half of that is 8, so each of these segments is 8. All right, so here's where the special triangles bit comes in. So this is the calculator section of the test, so if you wanted to, you could get out your calculator and do the Pythagorean theorem, right? A squared plus b squared equals c squared. However, it's much faster if you recognize that this is a 3, 4, 5 triangle times 2. So these are special triangles called Pythagorean triples, and there are only a couple of them that come up a lot on the SAT. One of them, as I just mentioned, is a 3, 4, 5. So this is just a simple right triangle that happens to have nice integer values for its side lengths. And so you can see it all over the test. Another one is a 5, 12, 13. Doesn't come up in this particular question, but it's very common, so it's a good one to know as well. Those 2 triangles are not given on the front page of the math test. They do tell you 2 special triangles, the 45, 45, 90 and 30, 60, 90, which are also very important for geometry and trigonometry questions, but they don't remind you of these Pythagorean triples. So they're very helpful. So in this case, we don't have to do the Pythagorean theorem. We can just look at this right triangle, see an 8, see a hypotenuse of 10, and just know that the other side must be 6, right? So 3, 4, 5 times 2, 3 times 2 is 6. So we've got a 6, 8, 10 special right triangle here. That gets us most of the way. Actually, we're basically finished with this question. Remember to actually answer the question. It wants to know what is the value of k. So in this case, the value of k is going to be the y coordinate of this circle. And so since we just figured out that the height of this triangle is 6, that's going to be the answer to the question. So if you're curious, we could also figure out the value of h, right? So that's going to be 4, what that point is, plus 8, so it's 12. So the center of this circle is 12, 6. Right, so the height of that line is 6, and that's the center of the circle, the y-coordinate, so that's the answer to the question. So I like this question because it doesn't look like a triangles question, but it turns out to be one. And the fact that it includes a circle is almost irrelevant, because all the usual information that you would consider about a circle, for example, the equation for a circle based on its center, that is irrelevant to the question. So even though it looks like a circles question, it turns out to be, like many geometry questions do, a question about special triangles. So don't forget about special triangles. They can be helpful on lots of different question types, just like this one.